Hello, for myself, Dr.R.R.S.NIMBALKAR, Physics Department, Annasaheb Awate College, Manchar. Now, we see TYBSc Physics paper number 1, Mathematical Methods in Physics. It is the paper of semester number 3. Okay, now we start in this paper differential equations. Now, you know, there are so many types of the equations are there. Out of that, we find the differential equations. Now, we call an equation is a differential equation when if in the equation there are differential terms. Differential terms means what? Suppose di by dt, delta y by delta x, delta 2y by delta x square, or delta 2 psi by delta y square. If such terms are present in the equation, then and then only we call such equation is a differential equation. Generally, there are the two types of the differential equations, and that are, one is ordinary differential equation and second is partial differential equation. Means there are two types of the differential equations. One is the ordinary differential equation and second is partial differential equation. Let us see the decay rate. Such a differential equation is dn by dt, this is equal to minus lambda n, or let us take the equation of SHM, that is d2x by dt square plus k by m x, this is equal to 0. This is the equation of SHM. See the equation of LCR, that is L di by dt plus I plus 1 by c into q, this is equal to 0. See, these are the three differential equations which occurs in physics. First is the decay rate, that is dn by dt, that is equal to minus lambda n. This is the differential term. Second equation of simple harmonic motion, and it is of d2x by dt square. This is the differential term. And here in the LCR equation, di by dt, I and q, these are the terms of differential. These are the differential terms. Otherwise, this can be written as L d2q by dt square plus R dq by dt plus 1 by c, q equal to 0. Here we put I is equal to dq by dt. We call this as a ordinary differential equation. We call this as a ordinary differential equation. Secondly, we find the partial differential equation. Generally, the Laplace equation in two dimensions, delta 2 psi by delta x square plus delta 2 psi by delta y square, this is equal to 0. So what is the difference between these two differential equations? Why this is called as the ordinary differential equation and why this is called as the partial differential equation? See here in this dn by dt, d2x by dt square, here d2q by dt square, dq by dt. Here d is there, here d is there, means here is the perfect differentiation. So we call this as the ordinary differential equations. Here in this term, d is not there, delta is there. Then what is the difference between these two differential equations? Where are the one variable and where are the two variables are there? Means here n is the dependent variable and this t is the independent variable. N depends on the t, but t not depends on the n. Therefore, we call t as independent variable n as dependent variable. Here in this equation d2x by dt square, x depends on t and t is independent. T is not dependent on the x. Means in this equation x is the dependent variable, n is the dependent variable, here q is the dependent variable and I is the dependent variable. And here t and here t and t, these are the independent variable. If in this equation, if there are only one independent variable is there. In this equation, only one independent variable is there. So we call this as a ordinary differential equation. Why this is called as the ordinary differential equation? Since in this equation, one dependent variable and one independent variable is there. The equations where only single independent variable is there, then and then only we call such differential equation as a ordinary differential equations. Okay, see the second, this is the Laplace equation, that is d/2 psi by d/x square plus d/2 psi by d/y square equal to 0, or let us write it as in 3 dimension d/2 psi by d/x square plus d/2 psi by d/y square plus d/2 psi by d/z square equal to 0. Here x and y, and here x, y and z. In the first equation, x and y are independent variables, while in the second equation, x, y and z are independent variables. Here psi is the dependent variable, in the second equation, psi is the dependent variable. Means in this differential equation, only single dependent variable there, but two or more than two independent variables are there. Here x and y are the two independent variables, and here x, y and z are three independent variables are there. Means if here more than two independent variables are there, then and then only we call it as a partial differential equation. If there are more than two or more than two independent variables are there, then we call such a differential equation is called as the partial differential equation. But in this equation, there is a single independent variable, so we call this as an ordinary differential equation. Okay. Next, to this, let us see what is the order of a differential equation and what is the degree of a differential equation. For that purpose, let us take these equations. See the equation, that is d2y by dx square plus 5 dy by dx plus y, this is equal to sin x. Let us take the equation d2y by dx square plus omega square y square equal to 0. dy by dx bracket q plus d2y by dx square, this is equal to 0. See x dy by dx plus 2 dy by dx bracket square plus xy, this is equal to 0. Now see what is the degree of a differential equation and what is the order of a differential equation. See here, we see what is the order of a differential equation. What is the order of this differential equation? For that purpose, let us see the first equation, that is the Laplace equation. In this Laplace equation, what is the order of a differentiation? Here, order of a differentiation, highest order is here 2, therefore order of this differential equation is 2. Here in this case again the same case, that is d/2 psi by d/x square. Therefore here the order given to the highest derivative. Here again d2y by dx square, here d2y by dx square, here dq. Means here the order of this differential equation is 2 and here the order of a differential equation is 3. See here x dy by dx plus 2 dy by dx square plus xy is equal to 0. Here is again order is 2. Means for this order is 2, for this equation order is 2, for this equation order is 3, for this equation order is 2, for this equation order is 2, for this equation order is 2. Means it is the highest derivative of which is present in that equation. Okay, next, after order we see what is the degree of differential equation. What is the highest derivative? This is the highest derivative. This is raised to 1, therefore degree of this differential equation is 1. This is the highest derivative. What is the degree of this, or what is the power of this highest derivative? That is 1. Therefore degree of this differential equation is 1. This is the highest derivative and the power of this is equal to 3. Therefore 3 is the degree of this differential equation. Here x d2y by dx square plus 2 dy by dx square plus xy, that is equal to 0. Here highest derivative is d2y by dx square. This is raised to 1. Therefore the degree of this differential equation is 1. Similarly for both equations the degree of this differential equation is 1. Now see what is the linearity of a differential equation. Linearity of differential equation. What is the linearity of this differential equation? See the equation. Derivative and dependent variable and its derivative. See, dependent variable and its derivative. Here dependent variable is y and what is its derivative? That is dy by dx. If in a differential equation dependent variable and its derivative, means the product of dependent variable and its derivative is not present. Here in this case 5 into dy by dx plus y, that is equal to sin x, means this is nothing but the linear differential equation. Because in this differential equation dependent variable and its derivative. What is dependent variable? Y is the dependent variable. What is its derivative? That is dy by dx. Means the product of dependent variable and its derivative is not present. Therefore, we call it as a linear differential equation. Otherwise, we call it as a non-linear differential equation. We call it as a non-linear differential equation. Again, in this equation, here d2y by dx square plus omega square plus y square. Here y raised to 2. Here dependent variable is there and there is no any power to that dependent variable. If there is a power to the dependent variable, here y is there, this y is dependent variable. If it is in power, that is y square or y raised to 3, Therefore, this differential equation is called as the non-linear differential equation. This is called as the non-linear differential equation. Again, this is the third equation. Here d cube y by dx cube raised to 3. Again, this is the non-linear differential equation because here the term d cube y by dx raised to 3 has the power that is equal to 3. Means for dependent variable and its derivative, if the power is 1, then we call it as a linear differential equation. Otherwise, it is the non-linear differential equation. Second thing is that in a differential equation, there is no product term of dependent variable and its derivative. In a differential equation, no product term of dependent variable and its derivative not occur, then it is called as the linear differential equation. Okay. Second thing, here y raised to 2, this term raised to 3 means this is in the power form. That is dependent variable, we don't want the power term of dependent variable and its derivative. So we call it as a non-linear differential equation. After that, order linearity, we see what is the homogeneity of differential equation. Homogeneity of a differential equation. Here we write the form of homogeneity differential equation as here a n x d raised to n y divided by dx raised to n plus a n minus 1 x b n minus 1 y by dx raised to n plus dot dot a1 dy by dx, that is a1 of x plus a0 of x into y. This is equal to f of x. Let us see, this is the differential equation. When this is called as a homogeneous differential equation, if the value of f of x equal to 0, then we call it as a homogeneous differential equation, and if f of x is not equal to 0, then we call inhomogeneous or non-homogeneous differential equation. See here, this is the linear differential equation. Here in this differential equation, in the right side, sin x is there. Therefore, we call this as a non-homogeneous differential equation or inhomogeneous differential equation. If RHS is equal to 0, means suppose this is the equation d2y by dx square plus 5dy by dx plus 7y. This is equal to 0, then we call this equation as a homogeneous differential equation, and this equation is called as the non-homogeneous differential equation. Means today we see what is the ordinary differential equation, what is partial differential equation, what is degree of a differential equation, what is order of a differential equation, then what is the linearity of differential equation, and next that is the homogeneity of a differential equation. Means here just we see if in an equation differential terms are there, then we call it as a differential equation. When we call as a ordinary differential equation, if the differential terms, means if there are only single independent variable is there, if there are single independent variable is there, then we call it as a ODE, that is ordinary differential equation. If in a differential equation, if there are two or more than two independent variables are there, if there are two or more than two independent variables are there, then we call it as a partial differential equation. That is partial differential equation. Next is the order of a differential equation. What is the highest derivative in that partial differential equation? This is the differential equation. What is the highest term? d2y by dx square. Here for this, the 2, that is the second order is given to this, and therefore what is the order of this differential equation? That is the 2 is the order of a differential equation. Okay? In this equation, what is the order? Here is the order. What is the order of this differential equation? That is the 2. Next is the degree. Next is the degree. The power of the highest derivative. What is the highest derivative in this term? In this term, in this differential equation, this is the highest derivative. And for this highest derivative, power is 1. Therefore, 1 is the degree of differential equation. Okay? Secondly, here d raised to n y divided by dx raised to n. In this differential equation, again, for this highest term, power is 1. Therefore, we call the degree of this differential equation is 1. And what is the order? Order is n. Power is 1, and power is nothing but the degree of a differential equation. What is the linearity of a differential equation? The next step, that is the linearity of a differential equation. If in this equation y is the dependent variable, what is its derivative? That is dy by dx is the derivative. In a differential equation, in a partial differential equation or in an ordinary differential equation, if dependent variable and the derivative, that is dy by dx, means the product y into dy by dx, or if a differential equation does not contain the term that is dependent variable and its derivative, the product of dependent variable and its derivative, if this does not contain in that equation, then we call as a linear differential equation. Secondly, here y is there, dy by dx is there, next differentiation, that is d2y by dx square is there. If there is no power, if there is no power of y, there is no power of dy by dx, or no power of d2y by dx square, or no power of d cube y by dx raised to 3, if there is a only single power for y, dy by dx, d2y by dx square, or d raised to 3y divided by dx raised to 3, then and then only we call it as a linear differential equation. Then and then only we call as a linear differential equation. Suppose here y square is there or any term is there. Suppose this is the y square. Then this is non-linear differential equation. This is not called as a linear differential equation. And last, that is the homogeneity of a differential equation. In a homogeneity of a differential equation, we see here when we call it as a homogeneous differential equation and when we call it as a non-homogeneous differential equation. Let us see, this is the differential equation which has the form, that is ANX d raised to n y by dx raised to n plus AN minus 1x dn minus 1 y by dx raised to n plus dot dot plus a1x dy by dx plus a0x y. This is equal to f of x. This is a standard differential equation, and in that standard differential equation, if RHS is equal to 0, that is f of x is equal to 0, then we call, if f of x is equal to 0, then this differential equation is called as the homogeneous differential equation. and if f of x is not equal to 0, then it is called as the non-homogeneous differential equation. Now we see the differential equations, that is partial differential equations, which occur in physics. That is frequently occurring differential equations in physics. Frequently occurring differential equation in physics, that is the first, that is the famous equation, that is the Laplace equation, that is del square psi is equal to 0, or in 2 dimension we write d2 psi by dx square plus d2 psi by dy square, that is equal to 0, or in 3 dimension d2 psi by dx square plus d2 psi by dy square plus d2 psi by dz square, this is equal to 0. Then that is the famous differential equation, that is Schrodinger's. Schrödinger differential equation, that is IH cross dabba psi by dabba t equal to minus h cross square by 2m del square psi plus phi psi. Then the famous equation of Poisson's differential equation, this is del square psi, that is equal to minus rho by epsilon 0, and somewhat Helmholtz equation, that is del square psi plus or minus k square psi, that is equal to 0. Means these are these differential equations which are occurring in physics. That is the first, that is Laplace differential equation. Here in the 2 dimension d2 psi by dx square plus d2 psi by dabba y square equal to 0, or dabba 2 psi by dabba x square plus dabba 2 psi by dabba y square plus dabba 2 psi by dabba z square equal to 0. Next, the famous equation in physics, that is the Schrodinger's differential equation. What is Schrodinger's differential equation is there? That is IH cross dabba psi by dabba t is there. This is equal to minus h cross square divided by 2m del square psi plus phi psi is there. Poisson's differential equation has a del square psi, that is equal to minus rho by epsilon 0. And what is the Helmholtz equation which are occurring in physics is del square psi plus or minus k square psi, that is equal to 0. We see in the detail, that is the Schrodinger's differential equation in the 3 dimension, and it can be written as IH cross dabba psi by dabba t. This is equal to minus h cross square by 2m. Here dabba 2 psi by dabba x square plus dabba 2 psi by dabba y square plus dabba 2 psi by dabba z square plus phi into psi. Otherwise, this differential equation also can be written as del square psi. This can be written as dabba 2 psi by dabba x square plus dabba 2 psi by dabba y square. If we put for that del square psi, it is in the 2 dimension, then it can be written as IH cross dabba psi by dabba t. This is equal to minus h cross square divided by 2m dabba 2 psi by dabba x square plus dabba 2 psi by dabba y square plus phi psi. This is the Schrodinger's differential equation which occur in physics.